Hello, this is Aiden Burchett, and this is my project on the memory architecture simulation. So going off of what we learned in class, is that a microprocessor has some sort of cache with their registers and ALU, and it links between that and the main memory with the RAM chip. And basically what the difference is that these two connecting have some latency between cache and memory. And so we want to optimize and find and explore different configurations of different ways of setting the cache and mapping it. So let's continue forward. As you can see, we have L1, L2, L3, and then main memory. And so these are all caches, and then this is the main memory. And there's going to be small latencies. There's going to be like nanoseconds. So it's going to be like, 10 nanoseconds here, 100 nanoseconds here, and then like 10,000 here. And these are all arbitrary values that I randomly made up. And so just for like testing. And so this is how the data is going to be organized. It's also organized the same way in my Python code. And so this is RISC-V, the main memory organization. As you can see, we have the main memory address, the index, the tag, and whether or not it's a hit or miss. And then as you can see earlier, that was direct mapped. So this is for associativity. So we have memory address, index, tag, and we have a way to see which one is going to be correct, like which way is going to be right or not. And then we have our hit or miss to identify if it's if the cache is in the data, right? Or in the cache level, sorry. So now we have direct mapping versus associativity. And this is where we're going to be comparing our benchmarks. We're going to have all three levels of cache, so L1, L2, L3, to be direct mapped. And we're going to compare that to a fully, associativity 8-way. And so that's what we're going to be comparing. And we're going to be kind of trying out different combinations, different configurations. That's my next slide right here. So like, for instance, for one, we're going to do direct, and then it's going to lead all the way up to 8-way. And so this is what we're going to be doing, and we're going to be testing this. And let's go look at the code now, and I can briefly explain through it. And so here's the code now. It's less than 400 lines of code. It's not too grand, but here's exactly what it was in class. We have our cache line. So we have our memory address, our index, our tag, our hit or miss. And we have this last used for LRU detection. I needed some help on that. And so we need this value right here. And then there's a memory organization. This is how we split our ways. So like associativity. So like right here says associativity, and it's set into different ways. And so we call memory organization right here with each level of cache. So each cache constructor has its own memory organization, and its own memory organization is determined by, itself. So let me just take you to a picture that's just easier to explain. So here's basically what I said. I have three classes. So I have a processor class that's right here, and I have a cache class that's right here, and I have a memory organization that's right here. So as you can see, this big box right here, that I'm highlighting in blue, this is the processor class. This is where everything encompasses. And then this is our cache class, where we have these different caches. So I'm going to highlight this in red, and then so L1, L2, L3, and so on. And then we have the memory, which is actually in green. And this is our memory organization to where we're actually going to store the data. And so I did use a little bit of AI for formatting. Nothing too grand. This is because I didn't want to deal with the formatting, but the logic, we do use a min heap to determine what is the least used, the least recently used, and then we pop it out. And so we use a replacement for direct map only, and then we use a swap function for associativity. And then this lookup is basically looking up whether the address is there or not, and it returns a Boolean, either true or false. And then from there, if it's direct map or associativity, it will do its thing. So let's go and let's take a look at the test cases. So here's the test cases. And so configuration 1, we have direct map, direct map, direct map. And as you can see, the associativity is set to 1. It's set to 1 on default if you don't put associativity. So you don't need this here, but you can have it here. And then, so it'll default to direct map. And then here's, our second configuration, and then we print everything. And then our third configuration, and so on. And this is the test list that we're going to be calling. So we have 3 sets of lists, and we have a memory list of high hits, a memory list of average hits, and a memory list of low hits. So we're going to run the program, and we're just going to see what it does. So let's go all the way back at the top. Okay. So which one's this one? So this is the configuration 1. So this is the first one. So this is direct map, direct map, direct map. And right now it's hitting a lot. It's at 14 hits with misses for being 2. And it's got a hit rate of 87%. That's pretty good. But this is the first list. And so, the next set of configurations, so from configuration 1 to 5, this is going to be the highest hit list. So for the next 5 configurations, we're going to see like the hits being way off the charts, and it's going to be super high because this is the first list. This is the high hits list. So let's keep going down. This is the direct map in 2-way and 4-way. As you can see, it's the same thing with the same amount of latency because it's a high hit. Here we go. We have the same one for a 2-way, 4-way. Okay, let's keep going down. We have the same thing, 14 for 2. And we have the 8-way for the final one, and 14 hits and 2 misses. So as you can see, it didn't really change much. There wasn't much change. But let's go to let's go to the average hits list. So this is the average hits list, right? So you have 6 hits and 10 misses, with a 37% hit rate. As you can see, the latency jumped. Okay, now let's go on to direct mapped in 2-way and 4-way. So here we go. As you can see, we're getting a lot more hits. We have more hits actually in the L2 cache than in the L1 cache. So here we go. So as you can see, we have a 25% hit rate in the L1 cache, but a 50% hit rate in the L2 cache. And that gives a lower latency value than what it was up here. This was like, yeah, this is in the 1 millions, and this is in the 600,000s right here. So that's pretty good. So let's continue going on down. This one's even lower. This is a 601,000 rather than 606,000 up here. And so, as you can see, the associativity is starting to pick up. And here's the 4-way, the 4-way, and the 8-way. It's kind of the same thing as in configuration 3. Let's go to the configuration 5 where we have full. And as you can see, we have the lowest right here. And so we have 10 hits with a L1 cache hit rate of 62.5%. So now we're going to go to the last list, which is the lowest hits. And so as you can see, we missed everything in the first one. So we have 16 misses. We have a 0% hit rate. So let's keep going down. And this is direct map 2-way and 4-way. And as you can see, again, we have, all misses. So, it's not too surprising because we're nearing we're in the lower levels of direct mapping. So let's keep going. And again, so 2-way, and 4-way, this had, 0 hits. Let's keep going. Okay, here we go. Now we have something. So we have configuration 4. We actually start hitting something. So as you can see, in L1, we have 4 hits at 25% hit rate. And we have in L3, another 4 hits with a 33% hit rate. That's a lot better than what we had earlier. Earlier we had, 1.6 million in latency and we had 0 hits. So now we have, 840,000. And this value right here is just arbitrary. It's just the latency values that I had. And so let's go down even more into the final one. And as you can see, 800,000 right here. So this is the highest hits for L1 cache. So as you can see, we have, hit rate 50%, and here's all of them. And here's exactly what hit. And we don't track the ones that missed because they're being replaced or swapped out. And yeah, and the values that I'm using are up here. So we have L1 latency is right here, L2, L3, and then main memory latency. And so that is the memory architecture project. It's nothing too grand, but it's something that I definitely had fun doing and building. This was really fun. And so I really liked it, and I really enjoyed, diving deeper into how the memory actually works and the different configurations you can use to reduce time. And so thank you so much for watching. I hope you have a good rest of your day. Bye.